Hello friends, I welcome you in lecture number 9 on functions. In this lecture we will discuss two questions on functions which were asked in GTU exam papers. So first we consider this question. Find the domain of the function fx equal to square root of 16 minus x square. This question was asked in GTU Winter 2020 exam. So we are already familiar with the domain of function. The domain of function is the set of values at which our function is defined, and here our function is given as fx equal to square root of 16 minus x square. So we have to decide or determine the set of those x values for which this square root is possible, and we know that square root is possible if our number is non-negative. We can define a real square root for non-negative real numbers only. So this function is defined if 16 minus x square is non-negative. The function f is defined for those values of x for which 16 minus x square is non-negative, and we have to decide those values for which 16 minus x square is non-negative. So we can write in this way that fx is defined if 16 minus x square is non-negative, that is greater than or equal to 0. Therefore we can rewrite this as 16 is greater than or equal to x square, or this we can rewrite as x square is less than or equal to 16. So if we consider this equality x square equal to 16, then there are two possible values for x equal to 4 and x equal to minus 4. So we can decide values of x for which function is non-negative in this way. Here I consider x equal to 4, here I consider x equal to minus 4. So I have to determine those values of x for which 16 minus x square is non-negative, and those values of x are nothing but those values for which square of x is less than or equal to 16. So we find that for x square equal to 16, possible values are 4 and minus 4. So equality will hold for x equal to 4 and x equal to minus 4. So now we have three regions. We are to the left of minus 4, we are in between minus 4 and 4, and we are to the right of 4. So first we check for this part. X equal to minus 4 is allowed because square of minus 4 is 16 and we have x square equal to 16, so that is allowed, minus 4 and 4. If I take any x which is less than minus 4, then its square is going to be bigger than 16. For example, if we consider x equal to minus 5, then square of minus 5 is 25, which is bigger than 16. So there is no x value to the left side of minus 4. Similarly, if we consider x to the right side of 4, that is x is bigger than 4, then also it is obvious that x square will be greater than 25. For example, 5 or 6, then x square for x equal to 6 is 36. So in this region also there is no x value. If we consider any x between minus 4 and 0, for example, if we consider x equal to minus 3, then square of minus 3 is 9, which is less than 16. Similarly, we can check for any value. So if x is in between minus 4 and 0, x square is going to be less than 16. Similarly, if we take any x between 0 and 4, including 0, then also x square will remain less than 16. So the possible values of x for which x square is less than or equal to 16 are in between minus 4 and 4, including minus 4 and 4, or we can write that the possible values are minus 4 less than or equal to x less than or equal to 4. So this set close interval -4 to 4 is the domain of given function. So we can write that domain of f is, we can write in different ways. We can simply write domain of f equal to close interval -4 to 4. If we wish, we can write our answer in this way also. We consider those real numbers x which satisfy this condition, -4 less than or equal to x less than or equal to 4. Okay, so this is very easy question. We are asked to find out the domain of this function, which is square root of 16 minus x square, and we are using this fact that square root is defined for non-negative real numbers only, and from this we obtain that x square must be less than or equal to 16, and values of x satisfying this condition are all the values in the closed interval -4 to 4. So therefore domain of f is closed interval -4 to 4. We consider another question which was asked in GTU Winter 2020 exam as well as GTU Summer 2020 exam. Same question was asked in both the exams. The representation is different. We can see here fx is given by 2x, gx equal to x square, hx equal to x plus 1. We are given three functions from set of real numbers to set of real numbers, and we have to find f composite g composite h and f composite g composite h. And here same function is expressed in another way, f from x to 2x. We know that we can write our function as fx equal to y, or same function we can represent in this way also, f from x to y, or image of x is y under this function f. Sometimes they can write in this way also, x tending to y, and here they write the symbol of f, or sometimes they can give us in this way also. So we must be familiar with these different expressions for the function fx equal to y, or f from x to y, or f from or x to y, and here we are writing f, or this is in terms of relations that we will discuss later, but this is also one notation for the function. So here in this question they have expressed our function in this form, and in this question they are using this form, x is going to 2x, x is going to x square, x is going to x plus 1. Both are the same thing. Here they have asked to find out these two compositions, and here they have asked to show that both are equal. So we got our answer also for this question. Here they have asked to find out these two compositions, and here they say that prove that these two compositions are equal, and we can simply use the definition of compositions to find out the different compositions here. And here domain and codomain are not specified, but we can see that all these functions are defined for all real numbers. Fx equal to 2x is defined for any real number. Similarly, x square is also defined for any real number, and x plus 1 is also well defined for any real number. So we assume that all these functions are defined on the set of real numbers, and their codomain is also set of real numbers, so that all these things are valid. F composite g, g composite h, okay, because we know that if we have g composite f, then this is defined if range of f is subset of domain of g. So here we assume that all these functions are from R to R, and therefore all these things makes sense. So first thing we will write is that here f, g and h are functions from R to R. Now first we find f composite g, or we can directly start for finding this f composite g composite h, f composite g composite h. This is also a function from R to R because all these are from R to R. So we find out value of this function at any x which is real number. So by definition, this is FOG of hx. We are using simply the definition of composition. We consider this as one function, this as another function, and we are using this definition. We know that if we have g of f at point x, then it is g of fx by this definition. So we are using simply this definition. So this we can write as f composite g, and definition of hx is defined as x plus 1. Image of x under h is x plus 1. So here we substitute hx equal to x plus 1. Again we use the definition of composition. So this is equal to f of g of x plus 1. And we now use the definition of function gx. Gx is given by image of x under gx is x square. Here instead of x we have x plus 1 square. Therefore we write g of x plus 1 equal to x plus 1 whole square. Now definition of f is image of x is 2x under function f. So f is sending x to 2 times x. If we have x here, we will multiply it by 2 to obtain its image. Here instead of x we have x plus 1 whole square. So we will multiply x plus 1 whole square to get the image of x plus 1 whole square. If we wish, we can specify what we are using. Here we are using the definition of fx. Fx is equal to 2x. Here we have used the definition of gx. Gx is given by x square. And here we have used the definition of hx, which is x plus 1. Hx is given by x plus 1. So this is f composite g composite h at any point x, and it is equal to 2 times square of x plus 1, and we give this number 1. Now we obtain this quantity f composite g composite h. So that is also a function from R to R. So first we write f composite g composite h at any point x equal to f of g composite h of x at any point x. This is by definition of composition. We consider this as one function, this as another function. Now again we use the definition of composition. This we can write as g of hx. I can use different brackets if I need. Now I use the definition of hx, which is x plus 1. Hx is given by x plus 1. Here we write the bracket. We will mention that we are using the definition of hx, which is hx equal to x plus 1. Now we use the definition of gx. Gx is given by x square. So instead of x we have x plus 1. So here we write square of x plus 1. And finally we use the definition of fx. Fx is given by 2x. So here we write 2 times x plus 1 whole square. So what we obtain, f composite g composite h at any point x, this is equal to 2 times square of x plus 1. So now we can observe that here also we obtain 2 times square of x plus 1. we can compare the right hand sides of 1 and 2, and we find that both the functions are equal. F composite G composite H at any point x, this is equal to F composite G composite H at any point x, and x is any real number, it is arbitrary real number. Therefore at every real number these two functions are equal. Therefore we can write equality. We can say that two functions are equal, F composite G composite H, and these two are equal. So, and this must be true because composition operation satisfies associative law. We have discussed in earlier lectures that composition operation is always associative. So if we write in this way or in this way, this is always satisfied for any given functions. And in this problem they have given particular functions and they have asked to check or verify that associative law holds for this composition operation. So we are just using the definition of composition of two functions, and we are able to find out these two different compositions. So this is all about this session. I hope you like it. In upcoming sessions we will discuss some more problems which were asked in GTU exams. Thank you.